Okay, so example 8, an observer notes that the angle of elevation from point A to the top of the space shuttle is 27.2 degrees. From point 17.5 meters further from the space shuttle, the angle of elevation is 23.9 degrees. Find the height of the space shuttle. So what I want you to recognize out of this picture is that this here to here is a right angle happening right there. When the space shuttle's set up, they have it pointing straight up, and they don't have it tilted. It'll be a bad day. Okay. And our task is to find out what V equals, and V is part of a right triangle. And if you look at the right triangle, either one, I'm going to focus on this one right here. If I look at that right triangle right there, if I can figure out the length of this piece here, let's call this H to give it a name. If I know what that equals, and 27.2 degree angle for V is the opposite side, and H for this right triangle is the hypotenuse, right? Just using SOHCAHTOA, I can figure out the value of V in this picture. Okay. The problem is I don't know what H equals. Or X. All right? But I'm looking at H because H belongs to this thin triangle over here, which I can look at and figure some stuff out. So, first thing I notice about this is if this is a 27.2 degree angle happening right here, that's 27.2. These two angles make 180, right? So 180 minus 27.2 comes out to 152.8. Hard to write in this tiny space. 152.8 degrees. All right. And when I figured out that angle was 152.8, and this angle, of course, is 23.9 given, and this side right here between point A and let's call this point B to give it a name, is 17.5. I'm looking at angle side angle information on this, right? So in this thin triangle over here, so just looking at this triangle, I've got angle side angle, which means the law of sines is usable to find missing pieces in that triangle, particularly H. Just to give this a name, I'm going to call this C. All right, so if I'm applying the law of sines here, I know that 17.5 over the sine of C is equal to H over the sine of 23.9. And that would be equal whatever BC is over the sine of 152.8, right? Equals BC over the sine of 152.8 degrees. Just with what I know about it, just again, the angle, side angle information I'm given, I know that much about this picture, right? Now, the other piece of information I have that will allow me to be able to work this out to figure out what H equals at least is if you focus on this part of the proportion that I've created. $17.5 is a number, 23.9 is a number, H and C are variables, and I'm only allowed to have one variable within an equation structure, right, to be able to solve something. Yes, Ashton?
Where did you get 152.8 from?
Because these two angles here, this angle and that angle formed a straight line. And a straight line has 180 degrees, so I did a subtraction. 180 minus the given angle equals the other angle. All right. So again, I found the angle inside the triangle here. I already had an angle inside the triangle, created the angle side angle. And then, the other thing I know about triangles is the three angles of a triangle, specifically this angle plus this angle plus this angle have to be 180, right? So the measure of angle C within that thin triangle, I'm talking about this ACB right here, is going to be 180 degrees minus the two angles in the picture. So minus 23.9 and minus 152.8. So now if I do 180 minus 23.9 minus 152.8. Angle C ends up being 3.3 degrees. All right. And what that does for me in this proportion is I can replace C with 3.3 degrees. And now looking at the blue highlights, that portion of the proportion can be solved now because I've only got one unknown in it. I do need to evaluate the sine of 3.3 and the sine of 23.9 to do it. So sine 3.3 equals sine 23.9 equals. And I'm going to replace sine of 3.3 with 0.0576. And I'm going to replace sine of 23.9 with 0.4051. And there really is no reason anybody should know the sine of 3.3 or sine of 23.9. So again, use your calculator to calculate stuff, but then record it on your paper so you have your work all there to look at, to follow the process. Once I get the proportion with all numbers, so number, 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 and h, I'm going to cross multiply to get h. So 0.0576h equals 17.5 times 0.4051. So that product equals this product. Again, that product's not something I can easily do in my head, so I punched in my calculator, hit enter, 7.0893. And I just continually keep rounding everything to 4 decimal places within my work. I want my final answer to be a couple decimal places, and that usually gives me a pretty accurate answer. So, the final step to find h, I'm going to divide by 0.0576. It's a pretty typical step in these problems where you have something times variable equals something, so you divide by the coefficient of the variable. So 7.0893 divided by 0.0576 equals, you get 123.0781. And again, it's not asking me to find h, it's asking me to find the height v, but by knowing what h equals, I have the capacity now to figure out what v equals by SOHCAHTOA. So if I look at this blue right triangle here, now I'm inside a right triangle, so now SOHCAHTOA is alive and well. If I look at SOHCAHTOA, and h is equal to 123.0781, right? H is the hypotenuse, we know that. V is the opposite, we want to know that. So because I know the hypotenuse and I want to know the opposite, sine is going to be the useful trig function that's going to help me get the answer. And particularly, we're dealing with, in the right blue triangle, the blue right triangle here, 27.2 degrees is the angle we're working with. So I'm going to have 27.2, so sine of 27.2 equals opposite, we don't know v, over hypotenuse we do know 123.0781. When I do SOHCAHTOA, I like to put my trig function over 1 to create a proportional look. Now I'm punching my calculator sine of 27.2. That comes out to 0.4571. And again, we're just at a proportional point here where we're going to cross multiply. The upward product here, 1 times v makes v. And the downward product gives me the answer I'm looking for. So 0.4571 times 123.0781 equals 56.26. I'm going 2 decimal places, my final answer, 56.26. And the unit of length on this is going to be the unit of length given in the problem. So 17.5 meters is the number we used. That's 56.26 meters is going to be the height of the space shuttle. Now, the homework assignment you're gonna have is gonna have word problems in it. It's gonna be up to you to diagnose what information you're given, what type of triangle it is, in order to establish, will law of cosines help me, will law of sines help me, will SOHCAHTOA help me? So, remember, for law of cosines, you're looking for side, 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 or side, angle, side. For law of sines, you're looking for angle, angle, side, angle, or side, side, angle. For SOHCAHTOA, it has to be a right triangle. So again, based on what you're given for information, that will help you determine what's the most useful way to go about finding the missing pieces. And this is just a mixture of two. Again, SOHCAHTOA lives in this problem, but we had to use some law of sines over here to find a part in the main triangle. I could have just as easily done law of sines to find out how big BC was. Then I would have had to do sine of this angle, 23.9, equals opposite over hypotenuse, or BC would have been the hypotenuse then. So it doesn't matter which one you go with, just make sure you evaluate things correctly for what you're looking at.